For certain in situ drilling operations, significant amounts of water are required to create steam to be injected underground. Because the steam condenses into water and is pumped up with the bitumen, the water can be recycled. However, because some water remains underground, a continuous source of additional water, about a half a barrel of water per barrel of bitumen, is required. These operations are located remote from large bodies of water and as a result rely mainly on groundwater. Where shallower freshwater aquifers are used, the continuous pumping of water can lower the water table. Because these groundwater aquifers are connected to lakes, rivers, and wetlands, reducing their levels can cause lakes to shrink and wetlands to dry out. As a result, some operators have switched to deeper sources of salty groundwater, but because they require fresh water, the salt water must be treated, which produces large amounts of salt sludge that must be disposed of. Both tar sands mining and in-situ operations produce large volumes of waste associated with their water use. For in-situ operations, the primary salty waste stream is disposed of in landfills or injected underground. Tar sands mining operations present a much more significant risk because they produce large amounts of waste in the form of mine tailings, 6 barrels of tailings per barrel of bitumen extracted. These tailings, a slurry of water, sand, fine clay, and residual bitumen, are stored in so-called tailing ponds, which are more like small inland seas covering more than 50 square kilometers. They are large enough to be readily discerned from space. One tailings pond at Syncrude's mining operation is held back by the third largest dam in the world. These ponds pose an environmental threat resulting from the migration of pollutants to the groundwater system and the risk of leaks to the surrounding soil and surface water. High concentrations of pollutants are found at concentrations in these ponds as great as 100 times natural levels, and although they are toxic to aquatic life, they are not regulated. Migratory birds fare only slightly better. To prevent them from landing, propane cannons go off at random intervals and scarecrows stand guard on floating barrels, occasionally to no avail. Air pollution from the oil sands is also rapidly increasing. Since 2003, Alberta has been the industrial air pollution capital of Canada. And then there is CO2. Canada was one of the first signatories to the Kyoto Protocol on April 29, 1998 and ratified the treaty December 17, 2002. In adopting Kyoto, Canada pledged it would reduce its greenhouse gas emissions by 6% below 1990 levels by the 5-year commitment period of 2008 to 2012. Canada's 2002 climate change plan committed the country to cut greenhouse gas emissions by 240 million tons a year by the end of 2012. It proposed a 3-stage strategy to achieve this goal through a combination of incentives, regulations, and tax measures. By 2006, however, Canada's greenhouse gas emissions had increased instead by 24% and have continued to rise ever since. With increased oil sands production using existing technologies, they cannot help but continue to rise. In an effort to differentiate themselves from the negative images of open pit mining, many oil companies are now touting their in-situ processes, which involve wells which have a similar surface profile to conventional drilling. They have no tailings ponds, but promoting these benefits as a virtue will simply mask the fact in-situ recovery is a necessity, because 80% of Alberta's bitumen is found too deep to be mined. The most common of these in-situ methods is steam-assisted gravity drainage, or SAGD, which involves heating bitumen with hot steam from an underground pipe, so that it begins to flow to a production well where it and the water generated by condensation of the injected steam is pumped back to the surface. In-situ extraction has been used in the tar sands for over 20 years, but production is growing rapidly and is projected to become the largest source of crude oil in Canada. While the visual impacts of in-situ tar sands operation are less than open-pit mining, they emit even more greenhouse gas emissions and will impact a far greater landscape.